Hi there, this video is about the structure of an atom, that is arrangement of subatomic particles in an atom and how to draw the structure of an atom, that is the nucleus in the center and the electrons revolving in the energy levels of the atom. We know that there are three subatomic particles which constitute an atom, and they are proton, neutron and electron. Proton and neutron, since they reside in the nucleus and hence they are collectively called as nucleons, whereas electrons are the subatomic particles which are found in the planetary of the atom, and they revolve in electronic shells. They revolve in electronic shell with fixed energy. The set of these three subatomic particles for an atom is called as subatomic composition of that atom. So in order to draw the atomic structure, one should be knowing the subatomic composition of the given atom. Now the structure of an atom can be drawn in two steps. Firstly, drawing the nucleus of the given atom, and secondly, arranging the electrons in energy levels of that atom. Now let us move on to the first step, that how the nucleus of an atom can be drawn. We know that nucleons, which are proton and neutron, they cluster up to form nucleus of an atom and sit exactly in the center of the atom according to Niels Bohr's model. Now the question arises that how many protons would be there in the nucleus of an atom. Answer to this question is equal to its proton number, which is denoted by capital Z, or atomic number. And this atomic number can either be had from the atomic symbol of that element or atom, or from the data booklet. For a general atom, this is the atomic symbol of the given atom, where X is the chemical symbol of the element, whereas this A is the nucleon number, sometimes also called as mass number, and Z is the proton number or atomic number. Now how many protons will be there in the nucleus of the given atom? That is given directly by its Z. So Z directly gives the number of protons in the nucleus of atom. Now in order to calculate the number of neutrons in the nucleus of the given atom, we use this formula. We know that mass number is the sum of number of neutrons and number of protons in the nucleus, but if we subtract the number of protons from the mass number, we get the number of neutrons for that particular atom. This N here, it represents the number of neutrons, whereas this A is the nucleon number, as already has been said. Now after having found out the number of protons and number of neutrons in the given atom, we can now draw the nucleus of an atom by just posting the number of protons and number of neutrons and encircling the cluster. In actual, there is no physically existing boundary around this cluster of nucleons, but for the sake of simplicity, this circle is drawn around the cluster of protons and neutrons, that is the nucleus of atom. After having drawn the nucleus of an atom, now let us move on to the arrangement of electrons in energy levels of an atom. Electrons are the subatomic particles which are found orbiting the nucleus of an atom in shells with discrete energy, much like the planets orbit the sun, but at very high velocity. Each energy shell can accommodate a certain number of electrons in maximum, and no electron can exist in the region between the shells. How many electrons in maximum a shell can accommodate, that is given by this 2n square formula, where n is the shell number or sometimes also called as orbit number. Now the question arises that how many electrons must be arranged in shells of an atom, and the answer is equal to its proton number, because atom is an electrically neutral particle, and it is possible only when number of protons in the nucleus equals the number of electrons in the planetary of atom. So how many electrons one has to distribute in shells of an atom, that is equal to proton number, which is Z. Now this arrangement of electrons in energy levels of an atom according to their increasing order of energies, that is called as electronic configuration or electronic arrangement. This electronic configuration is sometimes also called as electronic structure. This orbit number, that is small n, it is actually a non-zero positive integer, and its smallest value is 1 and increases as 1, 2, 3, 4, 5 and so on up to infinity. It is a non-zero positive integer, and it is particular for a shell. For example, first shell has n value of 1, second shell has n value of 2, third shell has n value of 3 and so on. Now let us see how to calculate the maximum number of electrons which can be accommodated in a particular shell. Shells can be counted right after the nucleus outwards, that is first shell, second shell, third shell, fourth shell and so on. First shell of an atom is denoted by capital K, also called as K shell, and for this K shell n value is 1 because it is the first shell of the atom, and it lies closest to the nucleus. It lies just outside of the nucleus of atom, and it can accommodate only 2 electrons in maximum. Number of electrons in maximum which a shell can accommodate can be calculated by putting the value of n in this 2n square formula. N value for the second shell is 2, and second shell is represented as capital L or L shell, and it would accommodate maximum of 8 electrons according to 2n square formula. Whereas third shell is denoted by capital M, also called as M shell. It has n value of 3 and accommodates 18 electrons in maximum, again according to 2n square formula. Now let us draw the atomic structure of some atoms. Say a hydrogen atom. Atomic symbol of hydrogen is 1H1. This is the simplest hydrogen atom or protium isotope of hydrogen. Now in this atom, since Z is 1, which is written at the bottom left of the symbol of hydrogen atom, so it means that its nucleus possesses 1 proton and its mass number is 1. Therefore neutrons in its nucleus will be 0, because the number written at the top left is mass number minus proton number, that gives you the number of neutrons. So there is only 1 electron revolving in the first shell of a hydrogen atom. So this is the atomic composition of a hydrogen atom. Now in order to draw its structure, firstly we have to draw its nucleus. So this is a nucleus of hydrogen atom, and it has 1 proton and no neutron, that is 0 neutron, and there is 1 electron that is revolving in its shell, which is the K shell, the only shell for hydrogen atom. This is the atomic structure of hydrogen atom. Now let us take another example. Carbon atom. Atomic symbol of carbon is 6C12. Proton number of carbon is 6, whereas mass number is 12. Subatomic composition for this atom would be protons 6, neutrons A minus Z. 12 minus 6 equals 6, and electrons would be equal to number of protons in the nucleus, that is again 6. So this is the atomic composition of carbon. Now in order to draw its electronic structure, firstly we have to draw the nucleus of carbon atom, which has 6 protons in it and 6 neutrons. This is the first shell, which should be possessing 2 electrons, one here and one here. This is the second shell, which would be possessing rest 4 electrons, say for example one here and one here. So for carbon atom we have to draw 6 electrons, which we already have drawn. So for carbon atom there are 2 electrons in first shell, which is the K shell, and 4 electrons in the second shell, which is the L shell. So atomic structure of carbon can also be symbolized as carbon has 2 electrons in first shell and 4 electrons in the second shell, since we have to draw only 6 electrons for carbon because its proton number or atomic number is 6. Similarly, the atomic structure of hydrogen can be represented in brief as H1. It indicates that there is only 1 electron in the only shell of hydrogen atom, which is the first shell. Now let us take another example, that is sodium atom. Atomic symbol of sodium is 11Na23. From its atomic symbol it is obvious that proton number is 11, number of neutrons would be equal to A minus Z, where A is 23 minus Z is 11. So there are 12 neutrons in the nucleus of sodium, and the number of electrons revolving in its shells would be equal to its atomic number or proton number, since atoms are electrically neutral particles, that is 11. So 11 protons, 12 neutrons and 11 electrons. This set is the atomic composition of sodium atom. Now let us first draw its nucleus. So in the nucleus of sodium atom there are 11 protons and 12 neutrons. After having drawn the nucleus of sodium atom, we have to draw the electronic shells and to arrange the electrons in them. First shell of sodium, like the first shell of all other atoms, would be having 2 electrons, one revolving in this energy level and the second is also revolving in the same energy level. That is, first shell can accommodate 2 electrons, and first shell is denoted by capital K. Now the second shell for sodium, it would be having 8 electrons in total. For example, 2 are sitting here, 2 here, and another pair sitting here, and another pair is sitting over there. Up till now we have drawn 10 electrons for sodium. Now in order to draw the 11th electron, we have to draw the third shell for sodium. There are 3 shells in sodium atom. So the 11th electron that resides in the third shell of sodium, which is the M shell. Electronic structure of sodium can be written in abbreviation as symbol of sodium, and in front of that we write the electrons accommodated in its shells from nucleus outwards. So first shell has 2 electrons, second shell has 8 electrons, and third shell is with 1 electron. Let us take another example of atom to draw its electronic structure, and that is calcium atom. Chemical symbol of calcium is Ca. Its proton number is 20 and mass number 40. Subatomic composition of calcium would be protons 20, neutrons would be 40 minus 20 equals 20, and electrons revolving in its shells would also be 20, equal to number of protons sitting in its nucleus. So this is the subatomic composition for calcium atom. Now let us firstly draw its nucleus. Nucleus of calcium has 20 protons and 20 neutrons in it. There would be 2 electrons in its first shell, which we already know that is K shell, and 8 electrons in the second shell, which is the L shell, drawn as 4 pairs. Up till now we have drawn 10 electrons for calcium atom, third shell, which is the M shell. It again has 8 electrons. Still 2 more electrons we have to draw for calcium atom, and those 2 electrons would go to the fourth shell of this atom. Instead of arranging in the third shell, fourth shell is denoted by capital N. So when the atomic number of an element is higher than 18, we see an anomaly. We actually come across an abnormality that instead of having space in the third shell, we arrange the 19th and 20th electron in fourth shell instead of third shell, and we know that third shell can occupy maximum of 18 electrons as given above by 2n square formula. However, when 8 electrons have occupied this energy level, octet gets completed and certain stability is given to the atom. In this way, the next 2 electrons go into the fourth shell, and then the remaining 10 electrons complete the third shell or third energy level. So the electronic configuration of calcium would be 2882 and not 2810. So this 2810 electronic configuration of sodium, it is not possible because this electronic arrangement does not give extra stability to the atom. So the electronic structure of calcium atom would actually be 2, 8, 8 and 2. Means first shell accommodates 2 electrons, second shell accommodates 8 electrons, third shell again accommodates 8 electrons, and the last 2 electrons, instead of arranging in the third shell, they arrange in the fourth shell, because this kind of arrangement, it gives extra stability to the atom. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry may not be missed. Sharing is requested too. Thanks for watching.